Ivani. So I'm gonna be your teacher for today. I'm gonna be teaching you guys mathematics. This is a very interesting topic, which I have decided to teach you guys since I have seen the gap. I've seen the gap. And so I've decided to teach you guys mathematics. I'm not only gonna teach maths, I'm gonna teach physical sciences and chemistry as well. So stay tuned for more lectures. So I'm going to start with a very interesting topic, the topic of number patterns. So basically, we're going to be going through sequences and series. It's a very interesting topic, sequences and series. Now, what are patterns or what are sequences? A sequence is an arrangement of things. A sequence is an arrangement of things. However, the way I'm going to teach it is going to be a little bit different. The way I define patterns is very different. According to my definition, sequences is the arrangement of numbers or in a function. It's an arrangement of functional value. Sorry, my bad. It's an arrangement of functional values. As you can hear, I've mentioned the term function. So there's a direct relationship between sequences and functions. So the functions that the sequences that I'm gonna focus on, we're gonna focus on arithmetic sequences, quadratic sequences, as well as geometric sequences. These are the only sequences we're gonna be focusing on. As I have mentioned, sequences are functions. Arithmetic sequences, an arithmetic sequence is derived from a straight line function. The straight line function. Now, the general equation for a straight line function is typically y equals mx plus c. Now, the arithmetic sequence, the general term for the arithmetic sequence is Tn equals a plus n minus 1 multiplied by d. The term a is represented by c on a straight line function. and the slope of the sequence function is the D. So your D is equal to M. That is why when we talk about arithmetic sequence, we're going to talk about a common we're going to talk about a common, I don't know what's happening. Okay, common difference. We're going to talk about the common difference. So as you can see, the slope or the value of M on your typical straight line graph is constant, meaning it's common everywhere. It's common everywhere. Therefore, whenever you deal with arithmetic sequences, you must think of a straight line graph. Now, we are going, you must think of a straight line graph. Now, let us go to the second type of sequence, which is the geometric sequence. Geometric sequence, general equation of the geometric sequence. Just like with the arithmetic sequences, the geometric sequence is a parabolic function. A parabolic function is given by typical function ax squared plus bx plus q, or c, or let's say c plus c. My bad. So the typical equation, geometric sequence function is an squared plus bn plus c. Plus c. As you can see, these two functions are similar. Your geometric sequence is a quadratic function. Now, how do we deal with this geometric sequence, and how does it look? A geometric sequence, just like any other sequence, it has terms. There's term 1, term 2, term 3, term 4, up term 4, term 5, up to infinity, which is the nth term. Let's say, for instance, term 1, if you substitute n equals 1 into this function, you will get a plus b plus c. Second term, you will get 4a plus 2b plus c. Third term, you will get 9a plus 3b plus c. And the fourth term, you will get 16a plus 4b plus c. For those who don't see where these values are coming from, if you substitute 1 into this equation, you will get this term. If you substitute 2 as the value of n into this equation, you will get that function right there. Same applies to if you substitute 3 into the equation. So what happens if we try to find the common, if we try to find the difference between two terms? The difference between these two terms is 3a plus b. Difference between these two terms, 9 minus 4, 5a, 3b minus 2b plus b. Third term, 16 minus 9, 7a plus b. By the way, before we move on, let me go back to the arithmetic sequence and explain the difference between two terms. Term 1, term 2, term 3, term 4. Sorry, I forgot to explain this. If you substitute 1 into this equation, you will get a plus, it's going to be a it's going to be, if you substitute 1 into the equation, you're going to get 1. But if you substitute 2, you're going to get a plus 2 minus 1, which is a plus b. If you substitute 3, you're going to get a plus 2d. If you substitute 4, you're going to get a plus 3d. If we try to find the difference between these two terms, a plus b minus a, sorry, it's not b, it's d. A plus d minus a, d. A plus 2d minus a plus d, it will give you d, because this is 2 minus 1, which is 1d. Then a minus a cancels out, gives you a d. If you minus this term minus this one, term 4 minus 3, you get 3 minus 2, 1. 1 minus 1, 0. So as you can see, on arithmetic sequences, there is a common difference. There is a common difference. Sorry for that. Let us resume on geometric sequences. As you can see, the first difference is not the same. Therefore, we will continue to find the difference. 5 minus 3, that is 2, 8. B minus B, 0. 2, 8. 7 minus 5, 2, 8. B minus B, 0. They cancel out. As you can see, there is a common difference. So the second difference, is the same throughout. The second difference is the same throughout. If you're solving a quadratic or a geometric sequence. Quadratic. Sequence. All right. I just want to highlight your functions. Your functions, that's your function. All right. Moving right along. Sorry, I made a very big mistake. This is not the geometric. This is quadratic. Quadratic. This is a quadratic sequence. A quadratic sequence is a parabolic sequence. My bad. Parabolic sequence. I made a mistake. It's not a geometric sequence. Number 3. Number 3, geometric sequence. Now, geometric sequence. Geometric sequence, just like any other sequences, sequence is a function, as I have explained. A geometric sequence is an exponential sequence. Typically, your exponential function will be y equals ax to the power n plus b. Now, in this syllabus, your sequential function will be given by a to the power of r, will be given by a r to the power of n minus 1. So if you, as you can see, these two equations, they have a similar form. They have a similar form. The only thing that we do not have is the shift in the horizontal asymptote, which is the value of b. It means the asymptotic value is 0 on this function. So we have two types of geometric sequences. We have divergent, and convergent. Now, this is a diverging function. Why is it called a diverging function? Because as the value of n increases, the value of Tn also increases. Meaning, if it is increasing, if we move the if we are moving along this function horizontally up to infinity, we will not reach a final value. Limit, as we move up to infinity, we won't reach the final value. Now, that is why we call it a divergent function. Now, I just want to draw a converging function quickly, which will make sense. I mean, something that converge, something that reaches a certain value over a certain period of time. Now, this is still an exponential function. And this exponential function will reach a certain value as the graph progresses. As the graph progresses, or as your n value increases, this graph moves closer and closer and closer and closer to your asymptotic line. That is why we call it a converging function. So now, what happens is, as we move along that graph, we'll reach a point whereby that graph will reach a certain value up to infinity. It is sort of like an imaginary value, but mathematically it will converge because as we move along, this graph is moving closer and closer to the asymptotic line. So that's why we call this function a converging function. It's a converging function. So normally a converging function will be in this form. A 1 over, if you increase the value of n, say, let's say to the power of, let's just say to the power of, now let's just say if the value of r is 1 over 10, let's say if the value of a, this value is, let's say 1. For instance, if a equals 1 and r equals 1 over 10, for instance. Okay, then this is going to be 1. So y will be, so for term 1, so for term 1, if n equals 1, we're going to have 1 minus 1, which is 1 times 1 over 10 to the power of 0. Any number to the power of 0 is 1. So this value will be 1. All right, so let's check what happens if we increase, let's say to the power of 2. If n equals 2, for instance. Then we will have 1 into 1 over 10 to the power of 2 minus 1, which is 1. This is going to be 1 over 10. This is 0.1. As you can see, the more you increase the value of n in this function, the more your Tn decreases. So it decreased from, let me give another example. Let's say if your n value is 3, so you're gonna have 1 is to the power 3 minus 1, which is 2. Let me take my calculator. This will be equals to 1 over 100, which is 0.01. If you go and plot, you will see that this function, when n equals 0, it will be there at around 1. And when we increase the n value, it gave us, this is 1, this is 2, this is 3. It gave us about 0. When n was 1, we got the Tn of 1. When n was 2, we got the Tn equals to 0.1. So let's say there. And when it was 3, the Tn was there. So this is the function that you're gonna typically get. So as you increase the value of n, as you increase the value of n on a function like that one, your Tn decreases. That's why we call it converging functions. That's why we call it converging functions. So your converging function you get a converging function when R is less than when R is less than 1. When your R is less than 1. When your R is less than 1. Your R is less than 1. When your R is less than 1. When your R is greater than 1, you get that function. All right. Moving right along. We are done with sequences and equations. So we're gonna move on to series. We're gonna move on to series. We're gonna move on to series. Now, we're gonna move on to series. Now, I forgot to write when R is greater than or equal to 1. You get that. All right. Now we have series. Then what are series? Series is the summation of sequence. All right. So let's start from arithmetic. Series. Arithmetic series. So let's say we are summing up term number 1, term number 2, term number 3, term number 4. Term number 1 on our calculations was A. Term number 2 was A plus B. A plus 2, sorry, A plus D. I always make this mistake. A plus D. D is the common difference. A plus 2D. A plus 3D. Where did I get this? It's coming from, as you can see, it's coming from these terms. All right, so if we sum all of this up until the nth term, the nth term will be A plus n minus 1 times D. If we swap the 2, if we rewrite the very same equation, but in a reversed manner, we will get n plus here the n minus 1 term, we will have a plus n minus 2 times d. So if we reverse, we're going to have n minus 1 times d plus, if we add all the sequence values, we will have something of that sort, plus a plus n minus 2 into d. We reverse it. Here we're gonna have to reverse it, gonna have a plus 3d plus a plus 2d plus a plus d plus a. Now, if we add these two terms, if we add equation 1, equation 2, if we add equation 1 plus equation 2, we will get, to add Sn plus Sn, we will get 2Sn. That's the sum of the series. That is the sum of the sequence, sorry. So here we will have a plus a, which is 2a, then plus n minus 1 to d. Okay, that's the first summation. The second one will be a plus d plus this term. A plus a, it will be 2a. Add d, if you add d plus n minus 2 into d, if you break down that term, you will have nd, you will have nd minus 2d. So minus 2d plus d is going to be a minus 1. So that term, d plus that term, eventually it will be nd minus 1, because it's going to be 2d minus d. So if we take out d as the common as the common factor, then we will be left with n minus 1 into d. Or you can approach it in this way. That d there represents 1d. That's 1d. And behind that d, we only have 1. So n minus 2 plus 1 will be n minus 1. And on the second term, or on the third term, if we're going to add that term there plus that one there. Sorry, I'm not gonna add that one. This one was supposed to be added with the, with one of the nth terms, but we don't have. But something that you will observe is that each and every time when you add these terms, you're always gonna get that. So 2Sn can be, if we're gonna add all the terms, can be represented by n into 2a plus n minus 1 times d. Because each and every time when we add the combination of the terms, we're always gonna get that. Therefore, Sn is given by n over 2 into 2a plus n minus 1 times d. Which can also be written in this form. N over 2 into a plus n minus 1 into d. I think this rings a bell. This is the nth term. So it can also be written as into a plus the nth term or the last term. Number 2, we're not going to do the quadratic summation because it's not part of the syllabus of the grade 12 syllabus. So we're going to do the summation for geometric sequences. Which is simply Sn is given by a into r to the power of n minus 1. I don't want to derive this one. It's a bit complex, but if you want me to derive it for you, I can do it. If you want me to derive it, I can do it on a separate video. If you want me to derive it, you can write on the comments. However, this function here is for a diverging sequence. Now, for a converging sequence, your Sn up to infinity is given by a over 1 minus r. So this is when r is between -1 and 1. So if your value of R is a fraction, it means your function will converge. This is it. This is a diverging function, and this is a converging function. At some point, this function will converge with the asymptote. So thank you very much for everyone who joined this series. On the next lessons, I'm going to do examples. On the next lessons, I will make sure that each and every derivation that I've made on this lesson is used. And everyone who has a question, you can go through comment section. You can also like my video. Please subscribe. Please like my videos. Please subscribe if you want more content. Thank you. See you on the next segment.